Hey, welcome to The Explainer. Today, we're digging into a huge environmental mystery that's been quietly building for decades, right under America's farmland. It's a story about a hidden debt that is finally coming due, and what it means for all of us.
So, let's just jump right in with a question that seems simple, but has a surprisingly complicated answer. Farming in the Midwest, it runs on nitrogen fertilizers to grow our food. But once that fertilizer hits the ground, its journey, well, it's far from over.
Okay, so our story starts right here, with the puzzle. In the huge farm belt of the Upper Mississippi River Basin, scientists noticed this simple but, well, kind of glaring accounting problem. The amount of nitrogen going into the soil just didn't match what was coming out.
I mean, it seems straightforward, right? You add up the inputs, fertilizer and manure. Then you subtract the known outputs, what the crops soak up, what washes into rivers. But the problem was, when they did the math, a massive amount of nitrogen was just missing. Year after year, it was seemingly vanishing into thin air.
But here's the thing, right? This stuff doesn't just disappear. So the big question became, where is it? And that's when a team of researchers decided they were going to become data detectives, using some pretty powerful tools to track it down and solve this mystery once and for all.
So how in the world do you crack a case like this? It's not like you can just go out and dig. Nope. You have to hunt for clues that are buried in decades and decades of records.
The entire investigation really started with this number, nearly 50,000 groundwater well samples. Now think about that. That's almost 50,000 individual clues, collected across 7 states over half a century, each one holding a tiny piece of the answer.
And their main investigative tool? A powerful machine learning algorithm called a random forest model. You can really think of it like a super smart digital detective. It can look at dozens of different variables all at once. I'm talking soil type, rainfall, how deep a well is, land use, and it can spot patterns that no human eye could ever hope to see.
And their process was super methodical. First, they fed the model all that well data, plus 74 other environmental variables. The model's first job was to find the signal in the noise, to figure out which 31 factors were the most important. And once it learned those connections, it could do something pretty amazing. It could predict nitrogen levels across the entire region, basically filling in the blanks on the map, even where there weren't any wells.
And all of that data crunching, all that digital detective work, it led to a massive breakthrough. They didn't just find the missing nitrogen, they revealed the absolutely staggering scale of where it's been hiding all this time.
It turns out the missing nitrogen wasn't gone at all. For the last 50 years, it's been slowly seeping down, past the crop roots, through the soil, and accumulating deep underground in our groundwater. It's formed this vast, hidden reservoir of what scientists now call legacy nitrogen.
And here is the jaw-dropping result of all their work. The model estimates that, on average, there are 328 kilograms of this legacy nitrogen stored for every single hectare of farmland. Just let that sink in. An enormous amount of chemical buildup, just sitting there, silently, right under our feet.
And to really put that in perspective, the amount of new surplus nitrogen that gets added each year is about 49 kilograms per hectare. That means the reservoir that's already down there is nearly 7 times bigger than an entire year's worth of new surplus. We're talking about a huge historical debt. And what's really amazing is how confident they are in this finding. The researchers actually cross-checked their work using a few different models. And while the exact numbers wiggled a bit, every single method pointed to the same undeniable conclusion. There is a vast, previously unmeasured reservoir of nitrogen locked away right under the surface. So, the mystery is solved. We found the missing nitrogen. But understanding the problem is really just the first step. Now we have to face the consequences, because this discovery has some pretty profound implications for our water quality for decades to come. So if you look back over the last 50 years, the data's pretty stark. Only about 1/5 of all that surplus nitrogen actually washed away into rivers right away. The huge majority, we're talking nearly 80%, it stayed behind, just building up in the soil and groundwater. And it's that 80% that's become the critical issue today.
You see, this huge underground store, it acts like a massive, slow-release chemical sponge. It's not stable. It's going to keep slowly leaking nitrogen out of the groundwater and into our streams, our rivers, and our drinking water for years, maybe even generations, long after it was first put on a field.
And the consequences of this slow leak are huge. It threatens rural drinking water. It means our rivers won't get clean for a very, very long time. It creates this conservation lag, which means that even if we do everything right on farms starting tomorrow, we won't see the results in our rivers for years. And all of this pollution eventually makes its way down to the Gulf of Mexico, fueling that infamous dead zone.
And look, the researchers who uncovered this, they state the conclusion in really stark, unambiguous terms. This is not a problem that's going to fix itself. It's a long-term environmental legacy that we are now being forced to manage.
And that leaves us with a final, really challenging question. When the pollution we're seeing today is actually the result of actions taken decades ago, it completely changes how we have to think about fixing things. How do we plan for a cleaner future when we're still dealing with the persistent chemical memories of the past?